All right, what we want to do for this question here is we want to match various exponential growth and decay functions to their respective graphs here. So these are all mixed up. We want to match these together here. So let's go ahead and get this started and try one of these out. So I'm going to take a look here at our first one. Let's look at y equals 2 to the power of x. And where is this on the graph? Where does this locate on the graph? Well, what are some characteristics of y equals 2 to the power of x? We know it has to be a growth function. So it has to be increasing as I read it from left to right. I know that it has to cross the y-axis at 1, right? If I let x be 0 here, we can see if I let x be 0, this would be 2 to the power of 0, in which case it's 1. And if we take a look at those characteristics, we can see here that a shares this characteristic. It is a growth function, and you can see here that it has a y-intercept of 1. That is not the case for this one. That is not the case for this one, for this one. This one is crossing below 1, above 1, below 1, below 1. Same can be said about all of these ones here. So right away, the answer for A is it's matching graph 15. Let's go ahead and look at y equals 2 to the negative x. As discussed, y equals 2 to the negative x represents a decay function. Again, if I let x be 0 here, this is going to be 2 to the power of negative 0, which is just going to be 2 to the power of 0, which is just equal to 1. So once again, I need a decay function this time that has a y-intercept of 1. And you can say here, this is out. This is not a decay function. This is not a decay function, not a decay function, not a decay function. And we can see here, this is a decay function for h, but it's below 1. Again, below 1, this one's out. Same can be said about all of these ones here. So continuous on here, we can see the answer for B is 16. Moving along here, let's look at 17. Now for 17 here, so you're essentially taking your y equals 2 to the x function and you're reflecting that in your x-axis. Doing so, this is our y equals 2 to the x function. It's going to look something like this. So I'm looking for a graph that looks something like this that crosses the y-axis at negative 1. And we can see here that is going to be h. So for set h, well, the answer will be 17. Now let's take a look at 18. So for 18 here, we're going to take our y equals 2 to the negative x function and then multiply that by a minus sign. So we have our y equals 2 to the negative x function. Will be this right here. And we're multiplying that by a minus sign, so it's going to go up and look like this time. And we want to see where does that exist for our function, in which case we'll see that exists at g. So the answer for 18 is going to be matching with g. Continuing on here, now we have our exponential growth function shifted down 3 units. So I'm looking for a growth function that has a horizontal asymptote at -3. So we need something that has a horizontal asymptote below the x-axis. That's either going to be here D, H, which is already taken, or I. And you can see here the answer for this, because this is a growth function, this is the only growth function that has a horizontal asymptote at 3. So the answer for 19 is that it will match with D. Now for number 20 here, we have to go ahead and create a growth function that is 3 above the x-axis, so we need a horizontal asymptote at 3, and the answer to that will be F. And continuing on here for 21, we need something that is shifted. This is going to represent a shift 3 units to the left of my standard growth function. So take your standard growth function, move everything over 3 units to the left. You can see here that the y-intercept this time will be very high. It will be 8. And examining this, we can see that that will match up with M. And for 22 here, now you'll see that the y-intercept here is going to be 1 over 8, because it'll be 2 to the negative 3, which is 1 over 8. Still a growth function, but that y-intercept is going to be 1 over 8. So we're looking for a growth function with a y-intercept of 1 over 8. And we can see here that is going to be E. All right, let's move on to 23 here. So for 23, I went ahead and I rewrote it in transformation form. And you'll see here for 23, what we're doing is we are essentially taking our 2 to the x minus 3 function, so that's this right here, and we're going to reflect that in our line x equals to 3. So doing so, we end up getting and creating the function c. So 23 will match with graph C. Continuing on here, looking at 24, we're going to take our exponential decay function, so what we see here in B, and shift that up 3 units. Doing so, we're going to be matching that up with J. So 24 will match up with J. And moving along here, we now take our exponential decay function and shift everything down 3 units. So now we have a horizontal asymptote at -3, in which case 25 will match up with I. And lastly, we have our graph of 26, which is going to match up with K. All right. Thank you, and that concludes today's lesson on graphing exponential functions.